Hi, in this video, we will take a look at how we can reverse a linked list. So all we are given is the head of a singly linked list, and our job is to reverse the list and return the reversed list, which means we are going to return the new pointer to the head of the linked list, which is reversed. So the example is pretty straightforward. We have a linked list in sequence 1, 2, 3, 4, 5, and the reverse linked list would look as follows, which is 5, 4, 3, 2, 1. Again, the second example, straightforward, 1, 2 becomes 2 to 1. And if you're given an empty linked list, we are going to return an empty linked list as well. So basically, there are two ways we can go about this. One is the iterative method, and one is the recursive method. So let me cover the iterative method first. So here, what we are going to do is that we are going to keep two pointers. Once again, one is that will point to the previous node, and one that will point to the current node. And what we need to do is to do some manipulation of the pointers of these nodes. So we are going to actually remap the next pointer in most of the nodes, and we will actually keep doing this in an iterative manner as in sequence of the linked list nodes. So let's get into the code and you will see what I mean. So two pointers, one is called previous, and previous will be initialized to none, and the current pointer we will initialize it to the head. Let's enter the iterative loop now. So we will have a while loop, and our condition is simple. While the current pointer is not none, which means we have not reached the end of the linked list. So the first thing I'm going to do is to actually initialize the variable called next, and this is going to point to current's next pointer. Now I'm going to update current's next pointer to be previous, and I'm going to update previous to be current, and finally I'm going to update current to be next. This will be easier if we can visualize this. So in the first instance, we are going to be having 1, which is pointed to by current, which is CURR in short. Our previous is pointing to none. What I'm going to do is that we are going to save this next pointer. So 2 will be saved in a variable called next. I'm going to update the next pointer for node 1 to point to previous, which is none. So 1 is now pointing to none. And I'm going to update the previous pointer to be the current, which is 1. And I'm going to update current to jump to 2. So what we have essentially done is we have broken this link of 1 to 2. Instead, we have shifted this link to 1 pointing to none, which denotes the end of a linked list. Again, similarly, in the second node, we would do the same. We would actually remap the next, which is pointing to 3. We will instead point the arrow back at 1. So we will remap the pointer from 2 to 3. We will break this link. Instead, we will remap this to point to 1. And then we will actually increment this pointer of current to go to the next node. So each time we are actually reversing the pointer to point to the previous node. So that's what this algorithm here does. So once we are at the end of the linked list, which means we have reached a point where current is actually none. So we are actually at this point where we've reached the end of the linked list and we are at none. What we need to do is to actually point the new head will become the previous. So the new head will be 5. So the current is actually at none, which means the previous is going to be pointing at 5. And of course that will be our new head. So the head becomes previous, and we just need to simply return head. So let's actually run this code, and we'll see that that's accepted. That's great, and let's submit this code as well. And great, so we have actually passed all the tests. So this is one way that we can go about reversing a linked list. Now let's actually take a look at the recursive method. So let me reset my editor here. So let's actually visualize the recursive solution. So I'm given a linked list. What I'm going to do is that I'm going to actually recurse all the way to the end of the linked list, and I'm going to remap all the pointers that are here. So firstly, I will need to break this pointer and point it to here. And when I reach the end of the linked list, I would actually return the current head here. So that would be my base case. So let's go ahead and try and implement the code to see what this would look like. So let's actually define a function which helps us with the recursive solution. So I'm going to call it reverse, and I'm going to give it one argument, which is the head. And in our base case, if the head is none, or if head.next is none, then we can just simply return the head. So when we return from recursive call, let's store this in a variable called current. So this would be the recursive call, and when we return, what we are going to do is to remap the next node's next pointer. So it might be a bit confusing, but let's write this out first. So the current head's next pointer's next pointer will be the head, and the head's next pointer will become none, and we will return current. So how this works is that, for example, until we reach a point where the head is none, we will keep recursing all the way. So at this point we will be actually checking if head.next is none, so 5 will be pointing to none, and that will be true, so we will return 5, and the caller in that recursive call would be 4, right? So we would have passed in 4 here, and 4 at that point we would have made a recursive call called reverse, and the head would be 4. At this point the recursive call will return head, which is 5, so that will be stored in current. We will actually remap 5's next, so this would mean that the current head, which is 4, its next, and this 5's next will point to head, which is 4. So basically what we're doing is 5 will now point to 4, and the current head.next, so this link to 4 to 5, we need to break that by actually pointing it to none. So when we point it to none, we are breaking this, and what we have done in this line is to actually say that 5 will have a link to 4. So we have basically reversed the link here, and we will simply return that current that we have gotten back from the recursive call, which is 5. So that is our new head of the linked list. So let's actually call this here, so reverse, and we will pass in the current head, and we will need to return that. So just noted a mistake here. In our line number 11, we have to call the recursion on the next node and not on itself. If we do this, this will be an infinite recursive call, so we have to call it on next. So what we're doing is basically to call the next node and recurse on all the way until the end of the linked list. So let's go ahead and run this code. So this is accepted, and let's submit this, and great, so all the test cases have passed. So that's the recursive solution for reversing a linked list. So I hope this video was really useful for you, and if it was, be sure to give me a thumbs up and subscribe for more upcoming videos. I'll see you guys in the next video.